Welcome everyone. It's Friday night and it means it's time for another coding challenge because I have absolutely no life. So this coding stream is for entertainment purposes only, and let's see what we've got today. So the goal is to try to crack one problem under 40 minutes. Oops. All right. So let's select the problem. Pick one. So what we've got. Oh, come on. Super slow internet again. Okay, medium problem, binary tree. Already feeling linear complexity. All right. Given the root of a binary tree, return the preorder traversal of its nodes values. Okay, a lot of people love it, but I didn't get a problem. So given the root, return the preorder traversal of its nodes. Like which one appears first, like in this case 1 2 3, in this case 1 2, in this case 1 2. uh, so there are negative values, so it would be interesting to see what are the how it does with negative values. But to be honest, I don't even understand why it's medium problem. Okay, let's am I still live? Seems like. Okay, let's see, let's switch to the whiteboard and try to print something and draw something. Let's start with circles. All right. Something like this. Something, oops, like this. It's very weird binary tree. It's not values. Preorder traversal, it's not values. So if it's like that, so the values, as I understood, that doesn't matter, but let's assume we have something like 5. Let's assume it's a good binary tree. This is like 7. This is 6, and this is 8. So then this is, let's say, 3, and this is 1. All right. So obviously this guy connected to this, connected to this. This guy is connected to this. I mean, to be honest, I don't see what's why it's medium problem. It's something like easy problem to me. If maybe I don't understand something in this problem, but it looks like all I need to do is every time I call, so for every node I first, if it's basically for every node I check now, right? No. So if oops, if it's no, so not now, then I add it, add to result, and add it to result, and then I call left, and I call right, where I bypass this result, whatever vector, I guess it would be. Result, right? I also even give indices. So we always go to the left first, then we go to the right. All right. So far it looks like this. Let's return back and see other examples. All right. So in these cases, 1, 2. I wonder if there are any example when they have on things on both sides. Follow up. Recursive solution is trivial. True. Could you do it iteratively? Like using queue? That's what you mean? Of course I can. So what's the problem? All right, let's use the queue. So, all right then. Let's start code. So, okay, we have vector of integer, which is our result, right? That's what we will return at the end. Oops. Return result. Now, so this one is what? Preordered BT values, or whatever we're supposed to return, how it's called. Given the root of binary, return the preorder traversal. Preorder traversal of BT values. All right. So, all right. So we do the queue of int. So the result. Okay. Yeah. Anyway, I thought we can save a little bit on the memory and say how many nodes we have, but technically we can't say this immediately. So while queue empty, right? Not empty. What do we do? Straightforward. So in queue, so we check here, so extra check, if root not now PTR, right? We do this. And so to the queue, let's insert. I can do this correctly. Oh, it shouldn't be int. It shouldn't be 3 node, right? Or pointers of 3 node, whatever. Insert. Right, should it be? Okay, yeah. Insert root. So here we say, I forgot. So QCPP. Let's see. So there should be 2 methods. One is to pop the element, and one is to get next element. So does pop access next element, remove next element. Okay. Front and pop. Push. It's push. It's not insert, it's push. Three node. Next is Q front Q pop. Oops, wrong. All right. So what do we do? Actually, we don't need this check, I guess. If it's now PTR, we can just check it here. So if next is not now, we do something, otherwise we do nothing, basically. All right. Weird. So extra, seems like extra. While, yeah, this is not needed. We say result pushback next. It's a pointer, right? And then what? Q push next left and Q push next right. I think that's it. Should be straightforward. Um, ah, wait a second. So the problem here and that it won't be the natural traversal order, right? It will be like preorder traversal. So in our case, let's go back to the whiteboard scene. If I understood the problem correctly, maybe not. We should first go 5, 3, 1, then 7, 6, and then 8. So they do not give example, unfortunately, when you have multiple, going to be like. So I would imagine these might be wrong. So in this case, if we need depth first search style of traversal, not breadth first search style of traversal, we might need to use sort of a stack, right? So we add it to the stack, we pop it from the stack, we then add it to this, we then pop, we then add, so it's always first will be all lefts and then it goes to the rights of things. So okay, so basically in the worst case, let's see here. In the worst case, we might need to change the queue to potentially stack for DFS like traversal. Let's see. And that, so we put root here. Let's say in this case, next here is 1. So it's not now. So we push to the result. Result now has 1. Sorry, let's do it like this. Has 1. So we put to the queue 2. We put null and 2. Left is now. So left is now, and here is 2. So on the next iteration, we pop null. It's false, then true. So we don't do this anything. So we can just skip it. This one we can skip, and this one we can skip. And then we go to the 2, which is also false because it's not now. Then we add it to the result, so it becomes 1, 2, right? Then we have the left one, which is 3, and the right one is null, right? So in this case, this will pass because it doesn't really matter. We have just one node at every level. All right, so we go to here. Right now we have what, 3, Right, it's false. It's false, so we add here another example. It's 1, 2, 3. Oops. So it's null because it has nothing, and it's null because it has nothing. And then we go again to now here. So, and basically after that we'll have another two nulls, right? Because we've edited from the tree itself. So now is true, so we don't do anything, and then true, we don't do anything, and then true, we don't do anything. All right, so then we will return here 1, 2, 3. So it looks like it should work in this simple example, but most likely we won't pass the tests. Let's see. And it fails here. Am I correct? Yes, I am correct. So now we know. So 1 has 4, 3, 2. I don't understand this simple, to be frank. It's 1 having binary tree 4 elements without having null. So 4 has 2 nulls, 3 has null and 2. I don't know. So the output 1, 4, 3, 2, because we go like in the order, right? It should be 1, 4. 4 has the 2, right? So that's why we need a stack. Let me check. Never remember any syntaxes except some stuff that I'm using constantly. Stack in C++, gig for gigs, right? Not Stack Overflow, whatever. It's also push, it's just the name stack, and then it's also pop. All right, so it seems like it's just one line change. Should we say it's run code, check that it works? Why it's so slow? No member front, okay. The stack is, so its entire stack size, they have top, right? So I guess it's top. Returns a reference to the top most element of the stack. Push adds. Pop deletes the topmost element of the stack. Okay, adds. Pop deletes the topmost element of the stack. Okay, so we just need to switch front top. Yeah, this is the problem. They didn't specify the way they want to traverse the tree. It can be breadth first search, so you go level by level, or it can be depth first search, so you go leftmost first, from leftmost to the rightmost, right? I think they should update the description, to be frank. Okay, it passes. Let's submit and see if now it passes. No, interesting. Why? So we add here. So we put the root here, right? So let's see on our example, right? So let's return back to the whiteboard. How much we like 20 minutes? Okay, have like about 25 more minutes. So in our example, we want return 5, 3, 1, I guess 7, 6, and 8. If I correctly understood what they want. 3, 1, 2, 3, 2, 1, expected 3, 1, 2. Uh-huh. Weird. So 3 has 1 and 2. Wait a second. Is it? How come we were able to return 2 before the 1? So 1, 2. Let's see. I guess it's, do we have it here? No, we don't have it here, of course. Something weird here. So they have what, 3, 1, and 2, right? So it should be, and you should return 3, 1, and then 2. So it's weird. And we return 3, 1. Oh! So because we add the rightmost, the last one, right? I see. Yeah, it's and we do this without recursion. So let me think a little bit. So we go to the left because it's the last one, then do it, and then at left, right? I think it's just because of, maybe wrong, but it seems like we should just push it first right and then left, because we first go to the leftmost and then to the rightmost. So that's the problem here. All right. So let me switch to the default scene so you see what I've done. So basically, so far, it was left and right. So because right was added the last one, we will go first to rightmost element and then to the leftmost element. And the problem is go to the leftmost element first and then to the rightmost element. So we switch them. Here, run code still should work. And submit. Hooray! We cracked it under, like what? Under 23 minutes. Yeah, so we even tested it. Of course, now those are not very correct one because that was for Q, and now we have what, 3 node. It's 4 milliseconds. I wonder though why it's slow. Okay, I've got that the memory we may resubmit it a few times to get better memory. Why the runtime is slow? Should we? So one potential way is do it like this, right? We can move it here. So it will be a little bit more a little bit less attractive visually. All right, and this thing we basically do again the same. So we kind of, before adding and checking after, we just do it immediately, so we don't do extra operations. We go now PTR, we do this, and same here. But as you can see, it's already visually is a little bit worse. I would better go with the first version. Now, in terms of memory, so here is the stack of pointers. Shouldn't be too bad. The result itself, we don't know in advance the size of it, so we can't really improve here in terms of memory, I guess. Can we? Yeah, I don't think we can. We also don't modify the pointer, so we theoretically can say it's constant. Maybe this will give us something, but I doubt. Q pop, Q top, Q pop, all of. So this is one operation all the time. Remove one pointer here. Then it's Q top everywhere. Won't be also that pretty. Right. Okay, so it seems it's working. So let's see if this submission will be slightly better. Oh, so first of all, this thing now should be here, and we should say root, right? So Q, if root, not now PTR. Actually, we can even move Q here because we don't need to do anything if root is now. Now, if it's not now, we push it to the Q. And we can say return result, so we don't need, but then we need to return result twice. Okay, let's keep it. If not now PTR, we add to the queue the root, right? And then if it's empty, run the card. So the rest should be the same. Don't understand why it says it doesn't know what the push is. So I broke it somehow. All right. Yeah. Don't see what's the. Because it's a const. We don't modify them anyway, so we may do this. Yeah, it's kind of super contagious when you add const. Now you need to add const everywhere. One more time. Error-driven development to the rescue. It should be, I feel like that's it, yes. And let's submit a few more times. I guess this is the best we can achieve in terms of speed here. I don't know how else to speed it up. All right, 0 milliseconds. Memory 72.5, so 72 points. Run a few more times maybe. Can we do better memory? Because memory sometimes can go down if you're lucky. Let's see. Oh no, it became worse. Whatever. So can I go back? Can I check this result, please? No? All right. Now 4 milliseconds. Okay, so it didn't change anything basically. It just jumps from 4 to 0. And so the best we got 100 points plus 72.5, whatever. Memory always sucks for me. I don't know. I've got 2 times 100%. Why it's now 4 milliseconds? Let's see. Okay, 0 and 8.4. Okay, it looks like the best results we can get today. So let's return back to the whiteboard. All right. Friday is fine. So we still have 100 points here. We're a little bit lower on the memory today, which is fine. It's 72, 70, round up, 73. So, well, yeah, I mean, at least we use stack. I don't know. Can't remember when I last time used it. They don't like recursion. Interesting. So the face is okay. It's Friday, so maybe it's super happy today because it's the end of the week. Nice. All right. Okay, it's done. So fireworks as usual. All right, some interesting fireworks here. Let's commercial, obviously. I know it's just not loading. Yeah, it was commercial. It just doesn't want to load. Interesting. My internet that bad? I don't know. All right. All right. Happy weekends and see you. Oh no. Oh no. I didn't switch the scene, so you haven't seen the fireworks, right? Let me show you how. All right.